Hello everyone. Today we're going to talk about new like the script for the movement and the camera movement as well. So yeah, so I just did a little bit UI, but I think it's better for us to talk about UI next time. So yeah, so let's see how this goes. Uh, okay, I think I need to turn on this. Can you hear this? Okay, so you can see the basically the camera is following the player, and then it's moving. Yeah, and then the player is moving as well, and with the sound, if you can hear the sound. Okay, so this is the um okay, so this is the demo that we are going to make today. Okay, so let's try. We create a level art, and then we create lighting, and then today we are going to create um, a script talking about the movement. Okay, so uh, you can create, you can kind of hide the blue bee that we mentioned last time, and then we create another C sharp script attached to the yellow bee. See yellow bee. We got a lot of stuff. Actually, I remove all the collider to here player one. Yeah, so we have a really clean game empty game object. Hold all the numbers, and then hold all the audio sound, rigid body, and B movement. Okay, so let's see. Okay, so we open up our C sharp script. Then first, we attach the C sharp script to yellow B. Yeah, okay. So basically, we are going to create two players. So public int player number, we put one, right? So basically, it's here. You go here, yellow B, and player number, it's one. And if later on we drag another player from B movement from another B, then we can set the player number to two. Yeah, then it's another um, player. So basically, we put the player number, we set it one, and then public speed, we put 12. It means that the speed, yeah, uh, we actually I put 10, but if there's like the override on C sharp, then basically 12 will be the newest one. So I mean we can just put 12. It's fine. Yeah, you can always change and rewrite. Okay, so public float turn speed 180. Yeah, in public audio source, and we can have different audio source. For example, like a movement audio, uh, engine idling, engine driving. So uh, engine idling means that um, when the bee is not moving, then what's the sound of it? Um, and as for engine driving, what's the sound for the driving part? So you can put all the audios that you found online. I found some cool audios. Mm, those are the audios that I found, and it's pretty cool. It sounds like a helicopter, so I think it fits to the this bee, like our character. Okay, so yellow bee. Okay, so and then as for public float pitch range, what does it mean? It means that because we are going to have two players, if we only have one pitch, the audio, if we only have one pitch, then it's hard for us to tell what's the difference between the two. So if we get them a range of difference of the pitch, for example, some one pitch is higher, slightly higher than another one, then we can tell the difference between those two. Yeah, so that's the pitch, it's the audio part. And then private string and movement access name. This means that the movement access name. And another one is turn access name. Private rigid body, yeah. And then we have another private movement input value, turn input value, and original pitch. Yeah. Okay. So what's the rigid body? First, we need to get the rigid body, get component rigid body. This before, like the old version, you need to use m rigid body dot something that you want. But we are in the newest version, so we need to use our variable. We create a rigid body called m underscore rigid body, and then get component rigid body. So later on, if we want to do like a kinematic, then all we need to do is m underscore rigid body dot is kinematic equals false. So that's the our code. It's kind of like a replacing this long code. If you didn't put this variable, and you might need to use get component bracket uh, rigid body that is kinematic equals false. So we can reduce some lines by doing this. So before the game was before the game start running awake, we call out the rigid body. Yeah. Okay. And then private void enable. Rigid body is kinematic true. If it is true, then please make it true on enable, because like kinematic is like for example, like it moves and not really restrict by the physics. So because we are going to move it according to our script or our key inputs, it's not really according to the the physics. So we might need to say true at the beginning. Yeah. And then private on disable, so our rigid body will say false. It's kinematic. We set it false. Movement value we set to 0. Initial number for 0. And then m turn input value we put it 0 as well. Then we put start and movement access name vertical plus and player name number. So basically you can go here Windows or project settings, input. Okay, we go here, input. So if we put the player number equals 1, then our input manager is set to horizontal 1, vertical 1, and fire 1. And if we put our player number 2, the second player, then we have another one called fire 2 and horizontal 2, vertical 2. Okay, so, and as for this, we will use the horizontal 2. Yeah, oh, sorry, this is not mouse X. Okay, sorry, just saw it. Positive is, negative is A, positive is D. Okay, so we take it out. So what it means is that if I use arrow left, means the horizontal negative, the -1. If I use the arrow right, then it means horizontal, the positive 1. If I use the vertical, I want to that my player do vertical, then if I put down, it's the negative 1. If I put up arrow, it's the positive 1. Fire is the enter. So basically I wanna those keys are for the player 1. And player 2, I use vertical 2, horizontal 2, and negative button I said A, positive button I say D. Yeah, it's like AWSD. Yeah, so S I set it to negative, and positive I set it W for the vertical key for the second player. Okay, so this is the yellow B. Okay, so here, move access name, our vertical plus M player number. Our turn access name we use horizontal, and plus, for example, if this is 1, then C# knows that, okay, so you want the movement access name is vertical 1. Vertical 1 will be the player setting input, vertical 1. So you can get the left to right, up and down, and enter as your player 1's key. Yeah, so that's the, yeah, on start, you also can change your pitch. Yeah, you set your original pitch to the movement audio dot pitch. It's here. So basically, audio, see like a movement audio's pitch, dot pitch. So it's here. So 1 is the original pitch. It's 1. Okay. Then let's go to the next one. Movement input value equals input dot get access. Okay, so start means that once the game starts, then we need to input get access. Put the for example like horizontal 1 or vertical 1. So we want to start get our input value. So input value equals this, get access horizontal 1, input access get access vertical 1, and then we start putting our engine audio. Then as for engine audio, then if the absolute math f dot absolute means that this number will be always positive. For example, like m movement, because like sometimes we will put a negative value, right? Sometimes, for example, if the player is going down or going left, that means it's negative value. So if it is less, so we always want this number to be positive so we can compare, right? If this number is less than 0.1f and this number is less than, it means like it's pretty slow. It's almost stop. So if this is almost stop, then we need to do something. We need to start to and okay, so if this is turning really slow and if the movement equals engine driving. Engine driving means that you are just driving. Keep driving. And then if those two are true, then please um, do those stuff. Okay, so please please make the move audio to engine idling. Okay, so move audio can be engine driving and can be engine idling. If everything goes pretty slow, then please replace to the engine idling. And movement audio pitch, please change the range. Yeah, cause like we want to separate the idling and the actual driving. So we want to make the sound a little different. So we use original pitch minus pitch range, which is 0.2, and the original pitch plus 0.2. Okay, so and then we start playing the idling engine audio. Else, okay, so if this is start kind of slow down, then we place the idling. If it is getting fast or not really, or this is greater, for example, if it is greater, and then please make it, and then the audio clip happens to be the idling, then please replace it to the driving one. Yeah, so if this audio clip is the idling one, please replace it to drive. Yeah, because this is else, so everything here is the opposite, so it's the greater or equal. Okay, so please make it driving, and please change the pitch, and please play. So basically this is just make sure that whether the input value, whether you hit it, you press your key long enough or short enough, that the value that you want to implement into your player is, if it is smaller than 0.1, the the value is less than 0.1 f, then please make this audio, the sound effect to engine idling. If not, please replace the move audio clip to engine driving. Yeah, so just make sure we have a good sound. Yeah, and then private void fix update. Okay, fix update means that this is a physics. Yeah, so anything related to movement, you need any constant physics change, then use fixed update. We need to make it move and we need to make it turn. So we use the fixed update. Then, okay, so let's see. Vector 3 movement. Okay, so this move, we are going to create a function for move because this is just code. You can basically do this because this can make everything looks simpler. Okay, so vector 3 movement transform forward, multiply, and movement input value, multiply speed, multiply time dot delta time. Yeah, so this means that the movement equals transform forward. Yeah, okay, so this is the transform forward, means that it's 0, 0, 1 in the 3 vector space. It's a z, positive z. And then multiply and movement input value. So basically, the value you just put on your keyboard, you need to times the speed and times that time dot delta time, just like move frame by frame. Yeah, and then rigid body dot move position, and rigid body position plus movement. So we want this move position from the original rigid body position plus the movement. Yeah, and then this one is that private void turn. If we have a turn, then turn input value is the key press that we press, that the value we give to the player. So the player knows where, like how long or how fast it can do. So this value needs to time the turn speed and time that delta time. Quaternion turn rotation. Okay, so we want Euler. We want this turn rotation to be only turn on y. This is like the rotation for quaternion. So quaternion, if we only want like the y to be turned, then we just write turn y. Okay, so so this is the turn. Yeah, so we only want y to be turned. Okay, so this turn will be this, the value of this. We just create a variable. Yeah, and then rigid body dot move rotation equals rigid body dot rotation multiply turn rotation. So it means that, okay, so I want this to rotate from this and times the turn rotation, the quaternion stuff. So so this can totally rotate later. Yeah, okay. So this is the code that we have for the yellow bee. And then let's see the next one. Next one is the camera rig. Okay, so as for camera, this is a little bit confusing. If you wanna watch the tutorial, can go to the tutorial. Let me show you the tutorial. Unity. Oh. Okay, Unity. Okay, let's see the camera control. Camera control. Yeah, you can take a look of this tutorial. Basically, it's pretty hard. So yeah, I was trying to understand it for for probably a day. And let me see how I can translate the uh, the whole script. Okay, so as for camera control, we need to set a camera rig and make sure the position is 000. Yeah, okay. And then main camera, we can set we need to create an empty object, and then game object, empty object, and then rename it camera rig and reattach main camera as the child object. And then we change the position. We just want to make sure the position is 000. So we basically take the main camera's rotation, put to here, and then we reset the rotation to 0. So basically just make sure the position is 000. Okay. Yep. Okay. So this is the previous setup, and remember to set the camera to orthographics, and size means like you see like the depth. Yeah, I think that's good. Okay. So yeah. Okay, so we are going to have the camera control, and we need to attach this script to camera rig. Okay, so what this script saying is, okay, so we create one public variable called m. M underscore it means like a multiple player. So if you have m underscore, and Unity will know that it's multiple player. So it's either player 1 or player 2. So you just put m underscore. Okay, so equals 0.2f. This means that you need some time for the camera to refocus. So it sets to 0.2f. And public float screen edge buffer 4f means that space between the top bottommost target and the screen edge. So for example, that we don't want our player just to be on the edge of the camera. We want to have like some little space. So this is like the little space between the top bottommost target and the screen edge. So we have a little edge. And public float, we want to make it 6.5. It's the smallest orthographic size the camera can be. So we don't want something to be super zoomed in. So we will see some weird small things. So we want to set it a minimum size. Okay, then this is all the targets. So right now we only set 1, so we are commenting it out. Later on, if we have 2, then we don't need to we can just hide it. We don't need to put. So right now we just comment it out just for right now. Yeah, and then we have some private of variables. For example, we create one called m camera, and this is the use referencing the camera. So yeah, and then private float zoom speed. It's a reference speed for the smooth damping of the orthographic size. Yeah, so you don't wanna suddenly just zoom in or zoom out. We want like more slowly, so it will look nicer. And then private vector 3, move velocity. It's a reference velocity for the smooth damping of the position. So those two are the reference. Later on, see, move velocity. So later on, because this is reference, so we need to put ref reference before it. Okay. reference means that whatever you put reference later on when you go back, it will overwrite. The reference will overwrite your current screen, like a current script. So that's the reference. Okay, private vector3 and desired position, the position that camera is moving towards. Yeah, so basically you want the camera to move towards the desired position. Okay, so on awake, we need to call the camera. It's similar to B movements like on awake. Okay, like super initiate, like a setup. We need to get a component rigid body first, right? So this is the same thing. We need to call the camera first. Okay, so private void fix update. What's fix update? Fix updates means that as for physics, anything move, turn, anything doing any action, or transition, or position, whatever, like anything related to physics, we need to use fix update. Yeah, so for example, like move and zoom, we need to use fix update, so the physics can update each frame. Okay, so what's the move? We create another function called find average position. So for example, if we have two players, this one and another one, that's open it, so you know. Okay, so for example, we want the camera finding the average position of like this distance, and we want something in the middle, and we want the camera to zoom that middle, that average. So the camera will not only focus on the first player and forget the second, or like the zoom will be really weird. So we want to always target on the middle, so both two can be all included. Yeah, okay. Okay, so we want to find the average position, and transform position equals vector3 smooth damp. Okay, it means that uh, uh, we want to transform our position, move kind of like slowly, and has its own like time to from the transform position to desired position, and we want to use the move velocity, yeah, to damp time. So we want this speed and with this time. And remember to put the reference here. So this is the smooth position. You see like vector3 smooth damp, vector3 current. So transform position is the vector3 current. And desired position is the vector3 target. So this is the current one. And desired position is the target one. And reference current velocity is the current speed, and to have time. Yeah, okay. So this is the move. And then we need to find the average position. Yeah, okay. So find average position is this function. We are here. Okay. So we want a new vector3, and then we assume the target is 0. Okay, so if we have 4 multiple players, let's assume. Okay, so it's like 0, 0, like 1, 2, 3, 4. So this I will keep increase. It's kind of like adding up, like counting, like go through each targets and see how many targets that we have. And okay, if the target isn't active, for example, like we have four tanks, and the third one happens to be the dead one. So we will count like 1, 2, 3 was not there. So we will be 1, 2, 1, 2, the 4. It will be 3, the third one. So so this is like counting like how many tanks, or how many or how many players still on the on the scene. Yeah, so if the game object is deactive, which means it's dead, it's out of game, then continue, but we won't really count it. And then average position is the targets, it's the I and position. So for example, we only have, before we have four players, now we only have three. Then those three, we are going to add all the three players position, just keep adding. Then if the number of, yeah, what if there's what if everyone died, right? If if there's no target, num targets, then we don't need to count, because there's no point, right? But if the the num targets greater than 0, then please make the average divided by the numbers. For example, we add up like a 3 players position, then we divide into 3. Then we can know what's the middle, the average position. Then average position will be the desired position. Okay, so keep the same y value. Okay, so the y means that the vertical part of our ratio, and then the desired position is the average position. Okay, then we want to do the zoom. So this is the position we wanna make our camera to reach to that position. Then zoom means that it's this. Okay, zoom means this. Okay, let me see. Zoom is this. Yeah, this is the zoom. Did you see this? Okay, so this is the zoom part. Not only our camera needs to go to the desired position, but also we need to zoom in the best view for our camera, for our game. Yeah. Okay. So we need to find the required size based on desired position, smooth transition net size. Okay, so we need to find the required size. And then the camera orthographics equals this one. It means that, okay, so our orthographic size is it's the current size, and the second parameter will be the required size. The third one will be reference current velocity, and the fourth one will be the time. So it's similar to the finding the position, smooth depth, but yeah, but it's more about the zooming. Yeah. Okay, so how to find the required size? Find required size is here. So required size, it's desired local position equals transfer versus desired position. Okay, so this means that finding a position that camera rig is moving towards its location. Okay, so this is the vector 3. And then we do the start camera size calculate at 0. Yeah, we start from 0. Then then we start counting like how many targets go through all our targets, how many players still alive in the scene. If there's some dead players, then please skip it. Let's continue. Okay, so otherwise find the position of the target in the camera's local space. Okay, so we need to find the target position. So yeah, we need to find it. Then we find the desired position. It's find the position of the target from the desired position of the local space. Okay, so this is if desired position to target equals target local position to desired local position. Then we need to start adding our size. Okay, so choose the largest current size and distance of the we can make player up, down from the camera. Okay, so this is the ratio. Ratio means that the top and bottom. Okay, let me draw this. Okay, so let's see. Okay, so this is the camera ratio. Okay, so this is the camera ratio, and then this to here equals y, and this to here, the center equals y. It's the ratio divided x. Okay, so basically this is the camera and this is the player. For example, if player is here, then all we need to do is to calculate the the y, and then if here, all we need to consider is the ratio part, x divided by y. Okay, so here all we need to do is to divide it by, so we need to choose the largest out of the current size and distance. So this is the time that we want, like make sure that our size, the maximum size, is from the size to absolutely so this is the y part. So this is the player, and we need to make sure that our maximum is the average point to the player point, like this y dot y, and we add up. This one is the first one, so we have the x, so this x need to divide it by the camera dot aspect. Choose the largest out of the current size and calculate size based on the tank being left or right to the camera. So basically this code, it means this is your player, and we want to know what's the maximum size for here to here. Okay, and then we need to this one is here, and later on the code will add up this, so the size will be this and this. So we are going to add, it will add up, basically. So the newest one size will add up to a screen edge buffer, and then size we are going to see, because we don't want to hit the minimum size, so our maximum size need to consider that the size is not hitting the minimum size. Then we return size. Okay, so this one is for game manager later on, and then we need to find the average position, transform the position into desired position. Then we need to find the required size for the camera, like this the camera, like the square, the zoom, this one. The square. this one. Yeah, the size. Okay, so yeah, so basically this is for today. No, it's all coding and it's a little confusing. I know I am still a little confusing about the code, but it's fine. We will get there. Okay, so that's the little demo. And I know there are some stuff that I didn't um, prepare well, but next time we are going to fix it. Okay, so for example, you see, I can go through my level art, which is something's, yeah, something is wrong, but we will fix next time. Okay, so yeah, so and the white circle underneath the player is the health bar. We will talk about the health bar later, but you can see like the camera is following the um, the player, and yeah, some of them are working, some of them we need to fix next time. Okay, so yeah, thank you for watching, and see you next time. Bye bye.